of water, more than 100 feet high.
These are huge numbers. These are just unbelievably large waves that we're talking about.
8,000 years ago, a massive tsunami decimated the Mediterranean.
That is the big problem with the tsunami. Just don't stop.
Prehistoric villages obliterated in an instant.
These were the forefathers of all the great civilizations of the old world. In the blink of an eye, everything that they had built suddenly washed away.
Did this ancient tsunami really happen? And could it happen again? Mediterranean Sea, 6000 BC. A wall of water taller than the Statue of Liberty races across the sea. The tsunami crashes into the coasts of 3 continents. Millions of tons of seawater rush ashore at more than 30 miles an hour.
Sounds like a freight train coming. So if you know something about tsunamis, you know what to do, and that's run.
A cheetah would be lucky to outrun this wave. A person really has no chance.
Ancient coastal settlements are obliterated in an instant. Seawater penetrates for miles inland.
The water level just starts to rise, and next thing you know, you have this entire torrent of a river running through the streets of your town.
From their perspective, it would have just happened instantaneously without any knowledge that it was coming at all.
Within hours, the storm has devastated villages for hundreds of miles. The entire eastern Mediterranean is in ruins.
It's pretty easy to imagine how terrifying it must have been to experience a tsunami because we know how terrifying it is now. It would just be a devastating experience.
For the Mediterranean, this is a scenario of catastrophic proportions. But 8,000 years after these lethal waves raced ashore, many questions remain unanswered. What caused this mega-tsunami? How devastating was it? And how did this affect the prehistoric people living along the coast? To understand how powerful this prehistoric megastorm might have been, we can look at its modern counterpart. The 2004 Indian Ocean tsunami. On December 26, 2004, a tsunami with the power of 5 million tons of TNT exploded across the Indian Ocean. Waves as tall as 40 feet obliterated coastal villages and towns.
It's just a monumental event. It's, take the worst hurricane and multiply it. The destruction was really very, very dire.
Unless you were on top of a mountain or on the top of a tree, you didn't survive, which is why so many people lost their lives.
The toll of death and destruction was staggering. More than 230,000 people killed in more than a dozen countries, from Southeast Asia to Africa. 1.8 million homeless. Damages totaling $10 billion. It gave the modern world a first-hand look at the awesome power of a tsunami.
Tsunamis are incredibly destructive. We usually think of water as being soft and gentle, but it's actually really, really heavy. A volume of water about the size of your kitchen stove weighs a ton, 2,200 pounds. It's like being hit by a car.
But even the largest waves recorded in 2004 were not as massive as the ones thought to have struck the Mediterranean 8,000 years ago.
8,000 years ago, the sort of architecture and engineering you saw would have just been obliterated by a tsunami. Even today, we see modern buildings, steel-reinforced concrete, just being raised by the power of these waves. So you can imagine a prehistoric stone building or a prehistoric wooden structure. It would have just been like a paper box just destroyed.
As in 2004, it is believed the waves from the ancient tsunami penetrated far inland.
That is the big problem with the tsunami, just don't stop. It's just a never-ending wave that goes in.
So if you have a plain, a very flat land, then a tsunami can move inland by many, many miles. We've seen that in 2004, the tsunami flooded about 6 miles inland.
Could the scene of destruction inflicted upon Southeast Asia have been a repeat of what happened in the Mediterranean 8,000 years before? Could this ancient storm also have obliterated thousands of miles of coastline?
Survivors in Thailand said there was no warning of the impending disaster. 11,000 people or more were
Unlike the 2004 tsunami, where the immense destruction and plight of its victims were documented for the world to see, this ancient storm unleashed its destruction long before recorded history. The victims and the scale of this prehistoric megastorm are a mystery. How might this tsunami have impacted the course of history? "8,000 years ago, the seeds of civilization were literally being sown on the coast of the Mediterranean.
8,000 years ago, people were just starting to settle down. We had the beginnings of agriculture in the region.
Known as the Neolithic era, this is a period when people stopped being hunter-gatherers and created the first permanent settlements. Some of the world's very first farmers probably made their homes along these shores.
The Neolithic was a real revolution in human society because for the very first time we could afford to stay put. We could become civilized because we weren't forced to be migrants chasing whatever large herd animals we depended on for food.
The advent of agriculture in ancient settlements throughout this region helped initiate the dawn of civilization.
Towns were springing up all along the coast of the Mediterranean. I mean, this was a real hotbed of the development of civilization.
Pretty much everything we associate with our modern Western way of life really does go back to what those people who were living around the Mediterranean gave birth to.
For more than 8 millennia, all evidence of this prehistoric megastorm would remain hidden. Over time, volcanic eruptions, the encroaching ocean, and natural erosion slowly erased evidence of this storm and its destruction. But in 1996, the first clue that an ancient tsunami may have been set off in the Mediterranean would be discovered in the most unlikely of places, nearly 2 miles up, on the top of a volcano. A team of researchers from Italy's National Institute for Geophysics and Volcanology, led by Maria Teresa Pereschi, was studying Mount Etna on the Mediterranean island of Sicily. Etna is Europe's tallest and one of its most active volcanoes. It looms on the very edge of the Mediterranean Sea.
This is a quite dangerous place to stay for a long time. If Mount Etna erupts just now, we are in the middle of the path of the lava flow.
Just below Etna's summit crater, in a region known as the Valle del Bove, the scientists discovered an area that looked vastly different from the rest of the mountain. They found sheer walls, 1,000 feet high, that suggested a giant chunk of the mountain fell violently away. Could this have been caused by a landslide?
The landslide started from the western wall of the Valle del Bove in front of us, and here is the northern margin, and it started from here and moved towards the sea in this direction.
With Etna positioned right on the edge of the Mediterranean, a large landslide could have easily crashed into the sea. And if the landslide was big enough and moving at a high rate of speed, the impact could have triggered a massive tsunami.
You know, if you have a lake and you throw a rock into it, you generate a wave. Now imagine this being a very big rock, being a big boulder. Now imagine it being, large masses of mud that are sliding into the water. As far as a tsunami is concerned, the entire world ocean is just one big lake.
The key to the severity of any tsunami lies in its trigger. Tsunami waves don't simply happen on their own. There has to be something to set them off. A massive energy source that initiates these waves and sends them surging through the water. The #1 cause of tsunamis is undersea earthquakes. That's what triggered the massive waves in the Indian Ocean in 2004. The seafloor ruptured suddenly. thrusting one plate upward and producing a huge bulge on the water's surface.
The amount of water that is displaced because of that earthquake can amount to up to about 2 times the explosive force that was used in World War I. We're talking the force of about 5 megatons of TNT.
As destructive as quake-generated tsunamis are, another trigger has the potential to unleash far more lethal tsunamis: a landslide.
If you jump into a swimming pool, you already make a bit of a wave. Now imagine something which is 1,000,000 times your volume crashing at a higher speed into the sea, and then you'll get the picture a little bit.
If the Italian research team is correct that a large part of Mount Etna tore away in a landslide, the results could have been devastating for the Mediterranean region. Stefan Greeley studies tsunamis at the University of Rhode Island. In a wave tank, he is able to simulate how a lethal tsunami wave is generated when a landslide slams into the sea.
Here we built a simple scale model of a landslide, just like a piece of a volcano falling into the ocean. It would be a huge block, and it would slide down, hit the surface, and create a big wave. So here it is. So all that energy of the motion of that big piece of rock will be then conveyed to the water and make waves, and then those waves will transport the energy all the way to very distant shores.
Is this the scenario that happened in the Mediterranean 8,000 years ago? Could a massive landslide have broken away from Mount Etna and set off a lethal tsunami that devastated coastal settlements? A team of Italian researchers believes it did. But to prove their theory, they must uncover hard evidence of this prehistoric megastorm and reveal an ancient tsunami to the world. 6,000 BC. All along the shores of the Mediterranean, prehistoric settlements are alive with activity. Suddenly, a massive tsunami races across the sea with the speed of a jetliner. Waves taller than a 10-story building crash into the coasts of 3 continents, obliterating everything in their path. But did this prehistoric megastorm really happen? What could have triggered it? How many villages would it have wiped out? And who were the victims? A team of Italian scientists is attempting to piece together evidence of this prehistoric megastorm and reveal how its destructive force may have altered history.
This wall of water spread toward all directions, flattening and breaking up into a series of waves.
The team believes the trigger for this tsunami was a massive landslide of debris from the volcano Mount Etna, which looms over the Mediterranean Sea on the coast of the island of Sicily. Landslides have the potential to create tremendously violent waves. The largest wave ever recorded was generated by one. In 1958, off the coast of southeastern Alaska, in Lituya Bay, an earthquake triggered a massive avalanche. The debris crashed into the bay with so much power that it sent water surging 1,700 feet up the other shore.
The wave generated in Lituya Bay in 1958 would have engulfed the Sears Tower had it been there. It was that tall. And this just scoured the land along the bay. It snapped full-grown trees like they were toothpicks.
Had that wave not been contained in a sort of natural bathtub, there's no telling how far it could have traveled, nor how much damage it could have done. Tsunami waves are packed with tremendous power and can travel thousands of miles in a matter of hours.
Tsunamis travel at high speed in the open ocean. They can travel about roughly 500 miles an hour, similar to jet speeds.
But as tsunami waves approach shore, they slow down. This causes them to bunch up and grow taller.
Once the tsunami reaches shallower water, it will slow down. So your wavelength is decreasing. So a good analogy may be then to think of a marshmallow. If you hold a marshmallow and you squeeze it horizontally, what happens is it has to expand vertically in order to make sure that it keeps occupying the same amount of volume.
The back of the wave is still moving faster, so the result will be a bunching up of the tsunami wave, and eventually it reaches a depth where it cannot be stable anymore and it breaks.
Is this the scenario of destruction that would have been seen in the Mediterranean 8,000 years ago? What if a massive tsunami raced across the sea, slamming into shore and delivering relentless waves of devastation? Italian scientist Maria Teresa Pereschi and her team think that's precisely what happened. They believe that the sheer cliffs located just below Etna's crater are evidence that a massive amount of the volcano broke away all at once and tumbled into the Mediterranean. The event would have looked very much like one of history's most famous volcanic landslides.
The whole side of the volcano collapsed sideways, very much like Mount St. Helens did in 1980.
On May 18, 1980, 8,000 years after Mount Etna's flank collapse, Mount St. Helens in Washington state suffered a similar fate.
The sequence of events related to the collapse of a volcano flank is probably extraordinarily fast. At Mount St. Helens, it took a couple of minutes to remove the whole flank of the mountain, then a few more minutes to lay down the avalanche over a length of about 20 miles. So it's extremely fast, and in the case of Etna, probably it was very much the same. Volcano flanks are notoriously unstable because the material is accumulating rapidly, and a lot of it is loose material, so prone to collapse.
It's like when children play with sand. They build up a mound, and then eventually this collapses on one side because it's just too tall and cannot stand up.
In order for the Mount Etna landslide to be the trigger for the ancient tsunami, scientists would have to prove both events happened at the same time. Radiocarbon dating analysis of debris taken from Mount Etna shows the flank collapse occurred 8,000 years ago, the same exact time frame as the ancient tsunami. But how big was the landslide? To create such a massive tsunami, the amount of debris slamming into the water would have to be enormous. In order to determine just how much actually entered the sea, Pereschi's team went in search of evidence of the landslide under the Mediterranean. They conducted an underwater seismic survey to map the sea floor.
Seismic surveys are sort of like X-rays or CAT scan of the Earth, where you have a sound source that shoots sound waves down into the Earth, and they reflect off of not just the seafloor, but other things in the subsurface. So it's sort of like a tennis ball. If you hit a hard table with it, it bounces back well. If you hit something soft with it, it just goes thunk, and it doesn't bounce back. So that's like the sound energy not returning very strongly. So you record the strength of those signals, and then you build up an image of the hard layers versus the soft layers, and that shows you what the geology is like.
The survey reveals the landslide sent 8 cubic miles of rock and earth hurtling into the water. The debris slid for more than 20 miles from the top of Etna, blanketing more than 100 square miles of seafloor. That's enough to cover all of Manhattan in a layer almost as thick as the Empire State Building is tall.
The amount of mass is staggering. It's hard to imagine the amount of Manhattan covered over by dirt is as high up as the Empire State Building.
Pereschi takes the evidence they gathered and begins plugging it into a computer simulation to try to recreate this prehistoric megastorm. Would this landslide have triggered an ancient tsunami that could have raced across the Mediterranean? Will the model reveal the face of this prehistoric storm and point toward potential victims? A team of Italian scientists is in pursuit of a prehistoric megastorm. They believe a massive ancient tsunami struck the Mediterranean, ravaging thousands of miles of coastline, potentially destroying countless prehistoric settlements. The team has discovered evidence that suggests a catastrophic landslide on Mount Etna in 6000 BC sent 8 cubic miles worth of debris hurtling into the Mediterranean.
So the whole sequence of events from the initial detachment of rock from the flank of Etna to the impact into the sea and the generation of the tsunami might have taken not more than 5 to 10 minutes. So the main event was over very, very fast.
Taking into account both the amount of debris found in the water and the slope of Mount Etna, calculations suggest the landslide would have hurtled downhill with a staggering speed.
The speed of a landslide coming from a volcano collapse can be very high. This can mean more than 200 miles per hour, which can be compared to a Formula One car.
That's an incredibly fast speed. It's really, really very fast. For a huge hunk of debris the size of Manhattan to be sliding down a mountain at that speed is just a colossal event.
They now know both the size of the landslide and how quickly it hurtled into the sea. With those two key pieces of evidence, Italian scientist Maria Teresa Pereschi and her team are able to create a computer model of the tsunami. For the first time in 8,000 years, they can see the storm that raced across the Mediterranean. The landslide creates initial waves 165 feet tall. The first area hit is southern Italy, pummeled with a 10-story tall wall of water.
If you could have a 165-foot wave created, it would be a huge monster.
And it is like a wall, like a cement wall coming at you on the beach. The impact of that amount of water can only possibly be related to the amount of force of an atomic bomb.
According to the model, waves from the ancient tsunami would have reached as high as 165 feet, larger than any wave in the 2004 Indian Ocean tsunami.
In 2004, there was about a 90-foot wave at its peak height, and looking along the coast, you can see basically all the vegetation and the towns and villages and everything that was there was removed. So a wave that was double that height would be about double the effect.
The simulation shows that after hammering Italy, the ancient tsunami would have raced on toward Greece and Libya, hitting those coasts with waves 40 feet tall. The tsunami would have roared ashore and penetrated far inland.
You know, imagine the Mississippi running through the streets of your town, taking with it everything. And if you're a person who gets swept into the water, your situation is very dire.
But the tsunami did not stop at Libya and Greece. The model estimates the ancient storm would have been powerful enough to reach the shores of the Middle East, more than 1,200 miles from Sicily.
The furthest extent of the tsunami would be the coast of Israel. The tsunami traveled very quickly towards it. It covered the 1,200 miles between Sicily and Israel in just 3.5 hours.
Such a vast distance is not unheard of for a tsunami to travel. In 1964, an earthquake in Alaska triggered massive waves that reached all the way to Hawaii, a distance of nearly 2,800 miles. The 2004 Indian Ocean tsunami traveled even farther.
Tsunamis can travel enormous distances. For this 2004 tsunami, traveled around the world several times and was recorded in far-flung places like Brazil and New England and Seattle. So there's really nothing limiting the travel of a tsunami, just the continents that get in the way.
If such a large tsunami were indeed generated even 8,000 years ago, there must be some physical evidence left behind. But the coastlines all along the Mediterranean yield no clues of destroyed settlements.
A tsunami could have completely wiped out some of the communities that would have been right along the coast. They would have seen in the blink of an eye everything that they and their ancestors had built suddenly washed away.
With no evidence of destruction on land, Pereschi and her team turn their focus to the sea floor for proof of the storm.
The seafloor is really the only place where you're going to see good signs of an ancient tsunami. The ocean tends to preserve those signs because layers of sediment that then rain down will seal it in there, and it'll be there for time to come. But land gets developed, and weathering and everything else that happens over timescales of hundreds of years really pretty much take away those signs.
Unlike normal waves, which generally only affect the ocean surface, tsunami waves reach all the way down to the ocean floor. As they race across the seafloor, the force of the tsunami stirs up layers of sediment, sand, and clay, creating pockets of disturbed seabed, which are the calling card of a tsunami.
So that's similar to if you have a cup and you have a bunch of sand in it and you start stirring back and forth with the spoon, the sand particles will rise into the water column. Now, in the case of a tsunami, the stirring is very, very pronounced. So it will actually lift off very thick layers of sediment into the water column and take it with wherever it's going, and then dump it wherever it starts slowing down.
Paresky and her team are looking for evidence of these disturbed areas all along the Mediterranean seafloor. For them, these pockets are like geological footprints at an ancient crime scene.
Marine sediments are like a continuously running tape recorder. Each thing that happens gets recorded in some way. So climate changes, earthquakes, tsunamis, all these things are all just in a continuous recording.
In the middle of the Mediterranean, Paresky and her team locate a cluster of disturbed sediment deposits. They find some along an underwater mountain range called the Mediterranean Ridge, and more off the coast of Libya in the Gulf of Sidra. Each of the areas falls in line with Paresky's computer model. Where the simulation predicted the seafloor would have been affected, the researchers find a pocket of disturbed sediment. But Paresky and her team have still yet to find signs of tsunami devastation on land. If a tsunami struck the Mediterranean 8,000 years ago, there should be traces of it along the coasts, where some of the world's first civilizations were taking shape.
If you track a tsunami and you go very soon after it happened, you're going to see a lot of signs on shore. Now, if you are trying to understand many, many years later, thousands of years later, what happened, it's a lot more difficult.
Paresky's team has found evidence of a landslide which unleashed the tsunami and traced the storm's path along the seafloor. But they are still searching for evidence of the storm's impact on prehistoric people. Could clues buried for thousands of years lead scientists to the answer of the lost tsunami? Years ago, a massive tsunami ravaged thousands of miles of coastline along the Mediterranean Sea. Until recently, no one suspected this prehistoric megastorm ever existed. Then, a team of scientists from Italy's National Institute of Geophysics and Volcanology announced a new theory. Led by Maria Teresa Paresky, they believe a catastrophic collapse of Mount Etna caused a colossal landslide, which triggered the tsunami and decimated coastal settlements all along the Mediterranean.
These waves stretched over the eastern part of the Mediterranean, in particular the Ionian Sea and its coasts, but also reached Israel.
The destruction you get after one of these tsunamis is like if a bomb had fallen in this area. You get rubble, you get trees uprooted, buildings just destroyed, and this can lead to just chaos.
To confirm her theory that a prehistoric tsunami ravaged the coast of the Mediterranean, Paresky must find some direct evidence of this destruction of ancient settlements. However, all along the eastern Mediterranean, from Italy to Greece to Libya, where devastation would have been the worst, she and her team find no evidence. No ancient villages destroyed. No remains of tsunami victims. No records of eyewitness accounts.
8,000 years ago, there's no writing. This is a very early time in our civilization, and there's just not very much record of any damage from a tsunami.
But on the other side of the Mediterranean, more than 1,200 miles from where the tsunami began, there is a startling discovery. The submerged remains of an ancient village that appears to have been abandoned suddenly around 6000 BC, the same time frame as the tsunami. Situated about a quarter-mile off the coast of Haifa, Israel, the settlement known as Atlit Yam was discovered by underwater archaeologists. In 6000 BC, Atlit Yam was located on shore, but rising sea levels eventually swallowed the settlement.
One of the reasons there is so little onshore evidence to go by of the tsunami is that the sea level in the eastern Mediterranean is about 30 feet higher than it was 8,000 years ago. So any coastal settlements have long been submerged.
Under the sea, archaeologists discovered human bones scattered about. Some skulls showed possible signs of blunt force trauma. Divers also found food stores that appear to have been suddenly abandoned by the villagers. Could this be the evidence of destruction to prehistoric coastal settlements, which proves this ancient tsunami happened? Paresky's computer model indicates that the tsunami could have traveled the 1,200 miles to Israel and still penetrated deep inland.
We tried to interpret some of the traces left in the village and connect them to a possible tsunami.
Paresky begins examining the archaeological remains through the prism of tsunami destruction, starting with possible signs of sudden abandonment. As was the case in the 2004 Indian Ocean tsunami, the suddenness of the storm would have sent waves rushing ashore, catching victims unaware.
One of the most destructive forces of the tsunami is the element of surprise.
If this tsunami arrives while you're sleeping, at night, when you're unaware, it'll just wash you away. You can drown right in your own home.
At Atlit Yam, archaeologists had found a huge cache of fish, which had been caught and then prepared by villagers for consumption or trade. Instead, the fish were abandoned.
The Neolithic era was not a consumerist one like today. Such valuable goods could not be thrown away, and that leads us to believe that all the goods were suddenly abandoned.
Archaeologists also discovered human remains with fractures and missing teeth. Injuries Paresky says are common among tsunami victims.
In 2004, the deaths were caused not only due to drowning, but also to violent strikes from objects that were transported by the tsunami and struck people.
Divers also discover some human remains randomly scattered about the site, a contrast to the formal graves located in other parts of the village.
Normally, the dead bodies of a Neolithic village would have been buried. We think that some of these scattered bones may be bodies of tsunami victims.
With each piece of evidence, Paresky becomes more convinced that a tsunami triggered off the coast of Sicily 8,000 years ago, raced 1,200 miles across the Mediterranean, and struck this ancient village. But not everyone is convinced.
The tsunami hypothesis is fascinating. It's a very, very interesting scenario. And it is possible. The potential hazard was there, but we cannot say by the archaeological evidence that it did happen.
Ehud Galili, the underwater archaeologist who found Atlit Yam, is skeptical that a tsunami is responsible for the settlement's demise.
When the village was occupied, little by little sea level have risen. We can estimate that the living conditions became so bad in the region of the village that they couldn't live there anymore. We don't have any archaeological evidence that can hint to this, but we estimate that little by little families left there.
Paresky acknowledges her skeptics, but remains confident her tsunami theory is correct.
Perhaps each discovery, each piece of evidence could be justified differently, but these same occurrences could also be linked to a single cause, the tsunami.
Proving something without a doubt in science is always difficult. In geology, it's virtually impossible. So what we find instead is a lot of disconnected bits of evidence. And we say, well, it's much more likely that this happened, but smoking guns are rare.
Who else could have been killed by this ancient megastorm? Are there more prehistoric settlements buried beneath the sea? Could the discovery of other sites reveal what might have been lost 8,000 years ago? Paresky and her team vow to look for more evidence to support their tsunami theory. They feel they're closer to understanding how a catastrophic landslide like Etna's can trigger such devastation.
Why is it fundamental to understand and reconstruct these events as neatly as possible? It's very likely what happened once in in the geological past will be repeated. It might not happen tomorrow, might not happen in the next few thousand years at Etna, but eventually it might happen again.
It's almost certain that another massive landslide could send debris crashing into the sea and trigger a devastating tsunami. But where will it happen? And who is at risk? In 6000 BC, a prehistoric megastorm ravaged the shores of the Mediterranean. Tsunami waves as tall as the Statue of Liberty raced across the sea, leveling coastal settlements from Sicily to Israel. What if this same catastrophic chain of events were to happen today?
Were an event like that to be repeated today would be cataclysmic, because the coasts around the eastern Mediterranean are very densely populated, starting with Sicily itself. So there would be probably millions of lives at stake if such an event were to be repeated.
Today, the Mediterranean coast is home to more than 140 million people. If a tsunami as massive as the prehistoric one were to strike the region, major population centers would be at risk. Devastating waves would race across the Mediterranean, striking Tripoli, Libya, Alexandria, Egypt, Tel Aviv, Israel, and Beirut, Lebanon.
We could be sure that all major coastal cities lying at about sea level would be inundated by such a tsunami. So the impact would be comparable to that of the 2004 tsunami in the Indian Ocean, perhaps even worse.
But another catastrophic flank collapse is not in the forecast for Etna.
Obviously, we don't think that this could happen tomorrow. Absolutely not. But it is important to study this tsunami, and in particular the landslide, since we still don't know what caused it.
Other areas around the world, however, are in danger of a tsunami impact. Some believe the biggest threat comes from the Canary Islands off the coast of Northwest Africa and a volcano known as Cumbre Vieja.
Cumbre Vieja is a mid-ocean volcano in the Canary Islands. It's proven to be much like oceanic islands around the world, that as they grow and evolve, their flanks tend to collapse.
An eruption of Cumbre Vieja in 1949 created an enormous crack in the volcano, pushing a huge chunk toward the ocean.
And the danger now is that another eruption sometime in the future could dislodge the entire half of this mountain and send it hurtling into the ocean.
Scientists fear that if Cumbre Vieja were to collapse all at once, more energy than the entire United States consumes in 6 months would be sent surging into the Atlantic, triggering the most powerful tsunami ever recorded.
The first waves would hit Morocco and the west coast of Africa about an hour after the landslide, and they could be up to 300 feet tall.
Computer models predict a wall of water more than twice as tall as the Statue of Liberty would hit parts of North Africa, wiping out everything for miles inland.
These are just unbelievably large waves that we're talking about. Once you cross to that level of just hugeness, the place is going to be wiped out.
The computer simulations showed the next to be hit would be southern Europe. Tsunami waves would then race west across the Atlantic, striking the Caribbean and the Americas, nearly 4,000 miles away.
These waves, as they radiate out from the source of the landslide, are traveling across the ocean at jetliner speeds, perhaps in excess of 500 miles per hour.
It's going to be like a fat man sliding into a bathtub. And it's going to pound into the eastern coastline of the United States with unimaginable effects. Everything from Boston south down to the Florida Keys is going to be on the receiving end of a gigantic wall of water.
Scientists predict waves as high as 165 feet could slam into shore, pulverizing the coastline.
You'd be looking at water that would be moving deep into states and pushing aside everything in its path.
If this tsunami were to strike, hundreds of millions of people would be at risk. The impact would be unheard of in modern times. Scientists do not believe this doomsday scenario of a Cumbre Vieja tsunami will occur anytime soon. but some are convinced it will eventually happen.
The important thing here is to know about the possibility, because if you hear about Cumbre Vieja erupting, you might think to yourself, maybe I should pay attention to the news. Maybe I should pay attention to whether or not there's a warning, and then you'll have a few hours to react to it.
Volcanic sources, and really all tsunami sources, are essentially like ticking time bombs. We don't really know what their clocks are, so it makes sense to go out and investigate them and see whether they're things we really need to be worried about in the short term.
Today, researchers are studying these ancient megastorms, hoping to find clues to future tsunami threats.
In geology, it has always been said the past is the key to the present. There's a strong need for understanding the processes that generate these phenomena, and there's an extremely strong need to inform the public and prepare the public.
Since the dawn of time, tsunamis have plagued the planet. These same lethal forces of nature that devastated ancient settlements thousands of years ago remain a danger today.